Hi everyone, I'm glad you are here today to watch another DevOps video lesson from International DevOps Certifications Academy. So today's subject is a great subject which will help you to understand why it's important to make your deployments safer in DevOps environment so everyone in your organization will get the benefits of being a DevOps organization. So today's subject is how do you enable low-risk DevOps code deployments in your production. So first of all, before we get started, before we deep dive into the specifics of this lesson, I want to quickly explain why this subject is such an important subject in the greater DevOps umbrella. In many organizations, we observe, these organizations are either agile organizations, they call themselves agile organizations, or Scrum organizations, or agile Scrum organizations, whatever you want to call them. What we most of the time observe is that these organizations, use, 2 weekly or 3 weekly sprints and then bring their code in either on a staging server, on even worse in code repository servers, and then they never deploy these codes in production systems. And then what they do is, after third or fourth month, they accumulated all these codes in non-production environments, they again do a big bang, and again, guess what? And there is again explosion. After Big Bang, everything collapses. The new features are not working, and the existing functionality is kind of broken. And then everyone, starts, kind of finger pointing. Who is the blame? Was this the fault of operations or the developers, or was the requirements broken, and was it missing? Where is the problem? And then all this firefighting, and in that what happens is, you build workarounds on top of workarounds, and then the quality is just a secondary subject, because now the primary motive is just to fix things as much as this as quick as this possible, and then the problem will simply evaporate, and then the next sprint cycle starts, and then this continues, and again the code is accumulated somewhere, and then again a big bang, and then again a big crash. This is kind of how things work in typical organizations. However, in high-performing DevOps organizations, we have been working together, such as Amazon or Google or Facebook or Netflix or Spotify or eBay. In these organizations, the day in life is completely different from the scenario that I just depicted. And today we are going to focus on the details. We are going to focus on some architectural deployment pattern. This great champion DevOps organizations use to be able to enable low-risk production environments, to be able to serve the best service for their clients. Okay, let's slowly get started. So in many IT organizations, you can observe production deployments are cumbersome and stressful. To stay in peace, this results to a tendency to reduce frequency of production deployments as much as is possible, because everyone is afraid of doing production deployments. Then organizations inevitably face deployments with larger batch sizes, which cause even larger problems. This is exactly the challenge that I just described a second ago. This vicious destructive cycle gets only worse, and it unfortunately represents the status of most of the largest organizations, including the ones whose core businesses are software and technology. This is really the ironic part of our business as IT professionals. The software, the companies whose core business is software and technology is even, most of the times, worse than, more miserable shape than the rest of the companies. But DevOps is hopefully here for us to change this, and everyone, will jump onto the DevOps train, and we will fix these problems. Your DevOps team has built-in control and risk mitigation mechanisms. You are now kind of starting, the underlying philosophy, underlying principles, how DevOps handles this. To begin with, we start with the philosophical, we start with the process-related aspect, then we come to the technicalities of how to enable, low-risk deployments with small batch sizes in quicker intervals, in shorter lead times. In a typical IT organization, development team builds software and operation team takes care of its deployment. In contrast, DevOps methodology shifts reliance of control and risk mitigation mechanisms from other independent teams to your own self-sufficient and competent team. To automate the deployment and peer review processes, again within your own team. So what happens in DevOps is, you never, as developer or operations professional or information security person or a coder or a tester, whatever, it doesn't really matter. You never rely on somebody else to make sure that this person, will enable the quality of your software. DevOps doesn't work like that. In DevOps, the quality assurance or software testing or test automation is not in the monopoly of someone else. It's in your own hands. Regardless what your job is, you can be a product owner, you can be a project manager, you can be a developer, you can be a tester, you can be a network specialist, you can be IT security specialist, you can be a database administrator. It really doesn't matter. Whatever your role is in your DevOps team, it's now your goal to make sure that you never rely on somebody else to make sure the quality and compliance is there. It's now part of your own job. You need to see the big picture to enable this in your DevOps initiative. And as all production and non-production environments as assets, which are as important as software your DevOps team produces, your DevOps team embraces 3 important principles. So principle number 1, ensure consistency of all environments in terms of operating systems, components, interfaces, patch levels, and all other dependencies, of course, your own software and configurations. I'm sure many times you observed that the environments you have tested your software is completely different from the production environments that you're supposed to install your code in the end, right? And then what happens is you test your software in the non-production environment, everything works great, and then you put it in your production, and then everything starts burning. This happens many times, and sometimes a reason as small as the minor version of Java virtual machine, let's say one Java virtual machine of 1.7.69 you have in your test environment. In your production environment you have like 1.7.55, and even this difference in the minor version of the Java virtual machine may cause that the software which work in your non-production environment does not work in production environment, and then in the end, of course, the toll is big, the thing doesn't work, and then the big crash. And therefore, in DevOps, you make sure that all production and non-production environments are as identical as possible. Principle number 2, it's a priority number 1 activity to fix an environment which breaks consistency of your environments. It's also very critical. If environment is broken, if environment that you're supposed to do your continuous integration is broken, then it really doesn't matter. You continue, writing new software, because there is no host, there is no nest for the software that you are building at a given time. Therefore, if something is broken, it's the whole team's joint responsibility to fix the issues, and then continue the building, and then installing, and then continuously testing, and then deploying your software. And therefore, environment impediments are again not the sole responsibility of network expert or operating system expert or the cloud expert or the data center experts. These people are anyway part of your DevOps team, and then it's the joint responsibility of the whole team to fix this environment issues as quick as possible, to be able to continue the correct development and deployment activities. Principle number 3, deploy with the same techniques to all environments, so rehearsal of your production deployments become one of your daily tasks and habits. This is a very, very important matter, very, very important principle. What happens is, especially in the big companies which do production deployment in every 3rd month, they most of the times, either put the code in the test environment with manual file transfer protocol, or they shut down everything and they play for hours, and then change configuration file, install software on the top of software, patch on the top of patch, and then they sometimes make it work. Okay, it's now working in the test environment, and then please explain me, what have you done in the test environment so that I can do the same thing in the production environment when the time of go live comes, and most of the times in 99.9% of the companies, there is no single development or architecture or operations person which can, correctly give this answer to you. And then guess what? Is you don't know how you deploy your software into production, and then in the night of go live, again, you start playing all around, install patch on the top of patch, software, and then fix this, bring this library, and then change this version, or upgrade this version, downgrade this version of this API, and everything. And then guess what? You have downtime like 48 hours in the production environment, and this is unfortunately how most of the crashes happens in even larger companies, because they haven't rehearsed production deployment in other non-production environments. And to be able to cope with this issue from now on onwards, it's you and your entire DevOps team's duty to make sure that each non-production deployment must be a rehearsal of your production environment, and you need to use the same scripts, same mechanism, same technology, same tools to do installments or to do installations in non-production environments as you are going to do later in the real production environments where you are going to serve your great services and products. Great, now we are coming slowly to the technicalities. Your built-in self-service deployment mechanism. So in the end, with DevOps, the idea is you automate as much as is possible, not only the testing itself. With one click, check-in, your code, will sometimes go to the production environments and then will be straight served to your customers, right? This is the level that you want to reach to DevOps, and this is exactly what I just said is the level of the champion DevOps organizations. And your automated self-service deployment mechanisms follows the following pattern or principles. Number one, code and check-in to the trunk. You never check in a development release or development branch in your code repository, and you keep your code there for weeks or months, and then try to merge everything, because merging the code from development branch to the trunk is your enemy. You have to stop this habit unless there is really a legitimate reason to do so. So you must do your development as much as is possible on the main trunk. So this is principle number one. Principle number two, build deployable packages. There is no intermediate release on the trunk which is not deployable. Therefore, in Scrum they say that in the end of each sprint you have to build a deployable release. In DevOps, this goes even to the more extreme. After each check-in, you must have a deployable software, and you not only have a deployable software, you also deploy it in non-production and even some cases in production environments. So this was principle 2. Principle number 3, validate deployment packages, dependencies, and configuration readiness. And the only way to do this validation is, of course, to deploy your code to the production environment. Number 4, validate environment readiness. Again, if the thing is working, if the test case of the existing features and new features are working, this is again the best proof that your environments are ready. Excuse me, my phone is ringing on a live lesson recording. Number 5, run automated testing. And this is again the same point that I was just explaining. You need to run automated testing. And number 6, record all validation and automated test results for audit and compliance reasons. Number 7, deploy packages to target environment. Number 8, run automated tests in target environment to validate deployment. Number 9, monitor system performance and activity metrics of target environments. Once you do a deployment, you just don't leave it there. You continue monitoring your tools. Will continue monitoring the CPU usage, the memory usage, the network usage. There will be security vulnerability checks, and then tons of test cases will be run, which validates the new and existing functions on your newly checked in software. So then you will have your peace of mind that the thing that you just developed will really delivers the benefits that it's supposed to deliver, and most importantly, it didn't break anything else in your software. And number 10, provide fast feedback, correct or roll back a deployment if anything goes wrong. This is the whole idea. If anything is wrong, then it's your duty to make sure that you fix the broken piece as quick as you can. Okay, the next part is your deployments are not identical to releases. What does this mean? With automated self-service mechanism to deploy your code to non-production and production environments, your DevOps team is now empowered and enabled to do daily deployments to your systems. Because every single deployment cannot be categorized as a feature or benefit release for your clients your team is serving for, your DevOps team needs to architect your applications and your environments in a way that releases do not require code changes and further associated deployments. This means that, we were talking about the go lives of organizations which do their deployments for every third month, right? And what they do is, they don't know to begin with before go live, what they need to do. And then, they start, crawling all around, and then they put, code on the top of code, patch on the top of patch, downgrade, upgrade, bring this piece, update this API, make sure this is connected, everything, all this chaos. And then, they try to bring up everything in 48 hours. In DevOps, basically, your release does not even require code deployment because you have been already deploying the code which constitutes your release, since already long time. And the release activity, the release action is most of the time as easy as, switching on a feature with the feature toggles that we are going to talk in few minutes. And then you switch on the feature, and then this feature will be served then to your customers. And of course, to begin with, you are not going to switch it on for all of your customers. You may want to get early feedback for functionality in development, or you may want to make a big release. But still, if you have if you are like a company such as Netflix, if you have 10,000 of servers on the field, you don't want to install a feature on the 10,000 of servers in one go, right? You may make you may choose the first few victim servers at the beginning. You may install your code on the first few servers, and then you monitor how the things are going on the servers, if they are still active, if they are still alive. To begin with, this is the first check, and then if they are working correctly for the existing functionality, and then if they also deliver the new functionality, then you have this confidence on the new functionality that you have just released, and then you continue releasing your software to another bunch of servers, and then after you have full confidence that your new feature, your newly checked and released didn't break anything, and then you release your code to every other server in the field. And this is how the champion organizations are working. And there are of course ways to do this. There are of course ways to enable this releases without even checking in any code, and now we are going to talk about them. And the first pattern to enable releases without code deployment is blue-green deployment pattern. So let's talk about what blue-green deployment pattern is. It's a very interesting one. One of the challenges with automated deployment is the cutover itself, taking software from the final stage of testing to live production. You usually need to do this quickly in order to minimize downtime, right? You don't want to break down your system for 48 hours, but unfortunately many companies still do this. The blue-green deployment approach does this by ensuring you have two production environments as identical as possible. At any time, one of them, let's say blue for the example, is live. In this example, let's say you have blue servers, that you see on the picture, they are live, and the green one is the servers that are, that you have been, continuously deploying your code. At any time, one of them, let's say the blue for the example, is live. As you prepare a new release of your software, you do your final stage of testing in the green environment. The green environment is the system under test, but it's not really a test environment. It's a production environment, which is only not really active at the moment because the blue environment is at the moment active. Once the software is working in the green environment, you switch the router so that all incoming requests go to the green environment. The blue is now becoming idle. It's like, you make first, your blue environment is the live environment, and then you keep on, deploying your software on the green environment. And the day of go live is like switching the traffic from blue to green, and then all the calls are going through the green servers, and then you keep on using the blue this time to update the new features, and then once there is a new release is ready, and then you switch off green and then you switch on blue, and then this goes on forever. And after one release, let's say I installed something on the green and I made the green live, but then suddenly I noticed that my release is bad, everything is crashing and there is a fire all around, and then what you do is pretty simple. You switch off via your router, you switch off the green the servers, and then you direct your traffic again all the blue servers, and then you're again safe. You rolled back without even rolling back any code, because you rolled back by switching the traffic to the correct set of servers, and then you fix your issue on the servers which have the problem. This is called blue-green deployment pattern. You have a set of servers active handling the live traffic, and you have another set of servers which are system under test, and then once system under test is okay, you divert your traffic to the system under test, and then they serve to your customers, and then you use the other set of servers which used to be live servers in the past. This time you use them for system under test, and then you keep on deploying new software on the top of them, and this switch on and off between two set of servers that we call blue and green deployment servers goes on forever. The next one is Canary deployment pattern. It's also a very interesting one. It's also called the dark launch. I will in a minute tell you why we call it dark launch. Canaries were once, canaries are the birds. Canary birds were once regularly used in the coal mining as early warning system. Toxic gases such as methane or carbon dioxide in the mine would kill the bird before affecting the miners, because the canary birds have less tolerance for methane and carbon dioxide than human. Therefore, signs of distress from the bird indicated to the miners that conditions were unsafe, and then they noticed that canaries feel uncomfortable. We need to do something. We need to either leave, or we need to do whatever their measures are to save their lives. Right? Inspired from canaries in mining industry, canary deployment is a pattern for rolling out releases to a subset of users or servers. The idea is to first deploy the change to a small subset of servers, test it, and then roll out the change out to the rest of the servers. The canary deployment serves as an early warning indicator with less impact on downtime. If canary deployment fails, the rest of the servers aren't impacted. This is exactly the use case that I explained from Netflix, right? A few minutes ago. What Netflix does is, they have 10,000 of servers on the field, and then they do once a new feature comes, they deploy the new software on a number of servers to make sure that the software is okay. And then once they have confidence, once the canary test passes, if the canary doesn't stress or doesn't die, then this means that the new software is okay, and then they keep on deploying the software to the rest of their servers. And Facebook, Google, along with many leading tech giants, use canary deployment pattern called the dark launch. They gradually release and test new features to a small set of their users before releasing to everyone. This lets them see if you love the new feature or you don't love it, and assess how it impacts their system's performance. Facebook called this dark launching tool gatekeeper because it controls consumers' access to each new feature. From the sketch, you also see how Facebook's dark launching mechanism is working. There are new features, and each feature is controlled with a feature toggle. They are either on or off. And then let's say you have a new feature that you see on the left hand side of the sketch, and then you switch it on for a certain set of users. Let's say you switch it on for the 5% of users who are in California, and then you collect the feedback from them. You assess their behavior, if they stick on this feature for a bit, or if they, as soon as they see they leave the feature, or there are bugs or errors, they assess the database logs, the software logs, and the user experience, how users can anticipate all these new features, and then if something is wrong, and then they switch it off, and then they keep on fixing. And sometimes sometimes, they enable, some feature, which is not even finished. They enable, for, let's say, for only 500 users on a town in the corner of Norway, let's say, and then, they observe, how they use this functionality, and then they assess again the behavior of users on the system by again checking the the logs and analytics and everything, and then they keep on developing this functionality. This dark launch is called dark launch because it's not clear to the users. It's not publicly announced to the users that okay, we now announce this great new feature, please use it. No, the dark launch doesn't work like that. In dark launch, the company simply switch on the feature for a bit just to collect the early feedback, and then after the feedback is collected, they switch off the feature and they keep on further developing and or the corrections of the software. As this new feature is not visible, this is why it's called dark launch. It's called dark launch because these feature launches are typically not publicized, but rather they are stealthily rolled out to 1%, then 5%, then 30% of users, and so on. Sometimes a new feature will dark launch for a few days and then you will never see it again. This also happens sometimes. Likely this is because it did not perform well, or the company just wanted to get some initial feedback to guide further development activities of DevOps teams. And the next deployment pattern is cluster immune system release pattern. This release pattern is an extension of Canary deployment pattern. It requires performance and software activity monitoring systems tightly integrated with your release process. In Canary deployment pattern depicted above, once the initial deployment on orange-colored server is done, your monitoring systems record all system performance and software activity metrics and generate early alerts if problems increase over certain threshold. This results in automated rollback if installed code from orange-colored server. This results in automated rollback of installed code of orange-colored server. So here, in summary, you basically, if you just assume that this orange and then this blue and everything is your production servers, right? And then you deploy your new software only on the orange servers here. And if something is wrong, you basically automatically roll back the software from the server. Then everything becomes again blue. And if automated tests on orange-colored server and monitoring system provide positive outcomes, your DevOps team is now far more confident to deploy their code to all other blue-colored server clusters too. In summary, cluster immune system release pattern offers for your DevOps team one additional safeguard for the issues that could be missed by test automation, because again, there is no test environment in the world which can guarantee 100% security. There will be for sure issues that you are going to first time monitor in your production environments. And then this Canary deployment pattern, especially cluster immune system release pattern, which is the Canary deployment release pattern empowered with monitoring and telemetry, will enable you, if something goes wrong on this orange server that you see on the picture, then you quickly monitor it. If let's say there is an infinite loop, then you will notice that your CPs will peak to the 100%, and then they will consume all the resource and memory and everything, and then you quickly monitor this, and then it alerts the system, and then you say okay, something goes wrong, and then you switch it off, and then you will roll back over the orange server. In contrary, if everything is nice, new functionality is working, existing functionality is working, all metrics, the resource consumption, the orders are flowing, all the requests are flowing, everyone is happy, no complaint from the call center or the business users, then you are confident that okay, your new release didn't break anything, and then you keep on rolling out your server to the rest of your server clusters. And then the second benefit is quick feedback and automated rollback action for production issues. First we said additional safeguard for the issues that could be missed by test automation, and then second, quick feedback and automated rollback action for production issues. Again, one idea, one major principle of DevOps is to build feedback loops everywhere possible. And again, this Canary deployment pattern in combination with cluster immune system release pattern will enable you to deploy quick feedback cycles, feedback loops in your rollback mechanism. This means if something goes wrong in the initial deployment of your feature of a limited number of servers, then you quickly get feedback and then you will have a chance to roll it back. This will give your DevOps team a great peace of mind, to make sure that they deliver quality work. The next one is feature toggles. We talked about this a little bit, but let's now formalize the definition about it. With feature toggles, you can switch on and off features of your application. Therefore, once all codes required for a certain feature are deployed in your production system, release of this feature is nothing but switching on your toggle. Feature toggles are usually settings in runtime configuration files or system configuration databases. Thanks to feature toggles, your DevOps team is now able to switch off a feature if a Canary deployment results in errors or suboptimal user experience. With feature toggles, you also have the ability to disable resource-intensive but relatively less important features if your system has challenges to scale. Therefore, even though your system may have issues to scale with all of its features, you can still enable your clients to get the best throughput from the most critical features of your software. As an example, in an e-commerce portal, you can temporarily switch off the toggle of viewing invoices so your checkout flow has more CPU and memory resources to consume. Furthermore, in the service-oriented architecture, your DevOps team can deploy different versions of services without switching them on. Once only versions of services required for a new feature or service flow are deployed, you can switch on toggles of these services to enable the new service flow. So this is exactly how deployment-free releases work, because during the work of your DevOps team, every day, not in the end of every sprint, every day, many times you deploy your code to the production, but many times on these features, this code is dormant, but still always fully tested, fully automated, tested, and then make sure that your newly checked in code didn't break anything. And then releasing a feature to your users is as easy as switching on a toggle, and then the users will quickly use these features. And other advantages, let's say before Christmas or Black Friday, all this let's say campaigns and everything, or let's if you run a portal for an airline company, you will have some peak times, right? And then if this happens, you want to make sure that your users, your customers are still able to book tickets, airline tickets. Otherwise, if your system can't scale and handle the requests from these users, you are not only going to use these clients, but your organization is also going to use money, right? And to avoid this, you may switch off, some, less important features, such as, viewing a past invoice, viewing past transactions, or even, viewing, all, tickets and everything. You switch them all this functionality. Just, give all the resources of your systems, to the checkout flow, so that your consumers or clients can still book their flight tickets, and then you are still be able to serve them and then earn money. And then once the peak time again passes away, then you can switch off the rest of the functionality and then check it out why your system had difficulties to scale it out. Again, these feature toggles will enable you to make sure that the resource intensive tasks are switched off, and the rest of the critical functionality have the resources to make sure that your software serves the feature that is supposed to serve. Okay, now we talked about the underlying philosophy to enable safer releases. We talked about the release patterns. Now we are going to talk about some architectural patterns which will enable to do some safer releases. So first off, there is no perfect one-size-fits-all architecture for all software products and services in all scales. When IT platform of a startup organization is initially built, a monolithic architecture is most of the times the first choice to ensure the quickest and cheapest entry to the market and to validate the business case. The problem with the monolithic architectures is that functionally distinguishable aspects, core functions, supplementary functions, users and system interface and integrations are all interwoven rather than containing architecturally separate components. During the lifespan of many large organizations, including Amazon, Google, Facebook, and eBay, they need to abandon their monolithic architectures in order to rapidly scale and enable low-risk releases and expansions of their features they serve for their clients. Their next direction was service or microservice-oriented architectures with the adoption of Strangler application pattern. Strangler application pattern to enable low-risk migrations to microservices. It's a great one that we are going to mention about this. Completely replacing your complex system can be a huge undertaking. Often you will need a gradual migration to a new system while keeping the old system to handle features that haven't been migrated yet. However, running two separate versions of an application means that clients have to know where particular features are located. Every time a feature or service is migrated, clients need to be updated to point to the new location. So basically, there is a big problem there especially during the migration process, because let's say you have 500 services, 500 functions, right? And if you do a big bang migration, you are doomed to fail. Therefore, being a big bang migration is not a question. Then gradually you will migrate your code to the new service, and then guess what? Let's say in the beginning we said you have 500 services, and then you migrated 10 of them. Then for these 10 new services which are working on the new platform, the customers we used to know the new interfaces to be able to use these 10 services, but for the rest 490 services which are still working on the legacy systems, they have to use the old interface. Therefore, there is a big problem there to maintain the migration process. And how we are going to solve this? Let me explain. Strangler application pattern incrementally replaces specific pieces of functionality with new applications and services. They create a facade that intercepts requests going on the backend legacy systems. The facade routes this request either to the legacy application or to the new features. Existing features can be migrated to the new system gradually, and consumers can continue using the same interface unaware that any migration has taken place. eBay is one of the first organizations which have used Strangler application pattern to migrate their legacy monolithic architecture into microservices. They started their migration by merely putting their applications behind well-defined universal APIs in eBay IT ecosystem, so they didn't have to rewrite all existing code in one single migration attempt. They reorganized their engineering groups with small teams from 6 to 10 engineers. A team as big as 10 people is now able to handle the universal API for the auction platform, which is the most frequently used auction platform in the world. So as you see with Strangler application pattern, you build let's look at the very left side of this image here. You have a facade, Strangler facade before early migration, right? And the customers, which are sending their request to this facade, even do not have any clue whether their requests are handled by legacy systems or by the new modern systems. And in the early migration, of course, most of the services will be still handled by legacy servers, and it's in a small number of servers will be handled by modern servers. But again, it doesn't matter for the client, because the universal API, the universal Strangler facade will make sure that the correct requests the correct request will be sent to the correct application backend server. And then in the later migration phase, as you see that now the legacy piece became smaller, and then the modern backend is became bigger, because the migration is now coming towards the end. And then once the whole migration is done, as you see in the very hand side of the picture of the image, the whole system is now using the modern API, and the migration is completed. And thanks to the universal API, which is encapsulated by Strangler application pattern, the migration efforts happened without informing the clients. It all happened behind the scenes without even informing your customers. And conclusion: in most of the IT departments, teams are not held responsible for building feature-proof scalable, and safer deployment patterns and their associated architectures. And yet, building an architecture and application features which enable your teams to do faster and safer deployments is a major prerequisite to succeed with DevOps. Only by enabling your teams to do low-risk, faster and daily deployments, you and your teams can reap the benefits of continuous deployments, smooth releases, and being a great DevOps organization that your clients will love. Okay, now we just came towards the end of this lesson. Today we covered how do you enable low-risk code deployment in your production environment. And I'm really glad that you take your time to work with me until the end of this lesson. Let me give you a brief heads up. What are we going to cover during the next lesson? The next lesson will be about how do you protect your DevOps deployment pipeline. It will be again a great lesson. Most probably I will publish in about a week. And again, I thank you very much that you spent your time with me today to watch this lesson. And I wish you a great day. Take care. Bye-bye. And I hope you saw what you enjoyed, what you saw here. Take care and goodbye.